Hey everyone, today we're going to continue our learning of ratios. One thing I noticed yesterday when I was watching the Flipgrids at home was that a lot of kids were having trouble with remembering that order matters. When you write a ratio, order does matter. And the question that I said to you about Mrs. Liker running 5 miles and walking 3 miles, um, a lot of you told me the ratio when I asked the question of how many miles did Mrs. Liker walk to how many she ran, you told me 5 to 3. But actually, if you notice the way that I asked that, I asked how many I could walk to how many I could run. So that would be 3 to 5. So there were only a select few kids that got that correct. So we will need to continue working on knowing that the way that a question is ordered is the way that we need to order our ratios as well. So today you are watching another video on ratios, and we're going to start talking about how ratios are equivalent and how we build them to be equal. So let's go over some vocabulary first. I have a pen, but again, I only use a pen because it shows up better on my paper. You should be using a pencil, and you need to be sure, guys, that this comes back to school tomorrow. So as soon as you're done with this lesson, you should take this paper and put it right in your take-home folder in the Return to School section. Thank you. Ratio, an ordered pair of non-negative numbers, so they're not negatives ever, which are not both zero. Can't ever both be zero. One can, but not both. A ratio is always a pair of numbers, such as 2 to 3, and never a pair of quantities, such as 2 centimeters to 3 seconds. Notice these are different units, and you can't write a ratio like that. So you can compare 2 centimeters to 3 centimeters, but not 2 centimeters to 3 seconds, because centimeters and seconds are not the same. A ratio is written A to B using the colon, A to B using the word to, and a fraction to indicate the order of the numbers. The number A is first and the number B is second. The order of the numbers is important to the meaning of the ratio. Switching the numbers changes the relationship. And that's why yesterday when I said Mrs. Liker runs 5 miles and walks 3 miles, but then I asked how many miles do I walk to the number of miles I run, it was important to say 3 to 5 and not 5 to 3. So the description of the ratio relationship tells us the correct order for the numbers in the ratio. So it's very important that we read that description of the ratio before we go ahead and order our numbers. Okay, example 1. The co-ed soccer team has 4 times as many boys on it as it has girls. We say the ratio of the number of boys to the number of girls is 4 to 1. Notice 4 times as many boys, that means there's 4 boys, and it says as it has girls, so that means there's 1 to every 1 girl. We read this as 4 to 1. We're going to create a table to show how many boys and how many girls are on the soccer team. So the number of boys is 4, the number of girls is 1. That means the total number of players is 5. Now, if I were to continue to build on this ratio, this is called a table, it's called a ratio table, I would continue to build up by 4 on this side, up by 1 here, and up by 5 here. So for example, if I want to build my team up, I need to add 4 more boys, which would give me 8, 1 more girl, which would give me 2, which would give me a total of 10 players. Okay, and I continue to do that pattern all the way down. It's called an additive. So we're adding 4 each time here, adding 1 each time here, adding 5 each time here. So I'm just going to go ahead and put a little note here. Okay, and then we would get the next one would be 12, the next one here would be 3, and the next one here would be 15. I want you to pause the video, and I want you to write one more column here. What would be my next number of boys, next number of girls, and next number of total players? Pause it and go ahead and do that. So I hope that you would have gotten 16, 4, and 20. Good. So we would have blank boys and blank girl on the team for a total of 5. That's the initial one. So they just wanted us to do this one, but I went ahead and did more just to kind of show you that we just keep adding on. It's called the additive. So is this big enough for a team? 5 players? Well, those of you that play soccer, the answer is no. Not for a traditional soccer team, but maybe it's a pickup team or maybe it's 5-on-5. Who knows? It could be. But that's just something that we can say no to because typically 5 players is not enough. What are some other options that shows 4 times as many boys as girls or a ratio of boys to girls of 4 to 1? Add the options to the table above, which we already did. So if we write 4 to 1 as a fraction, That's a ratio. And we write 8 to 2 as a fraction, and we write 12 to 3 as a fraction, and 16 to 4 as a fraction. Are all of these fractions or ratios equivalent? And the answer is yes. If you look, to get from 4 to 8, we multiply by 2. To get from 1 to 2, we multiply by 2. That means if we can multiply the same number by both the numerator and the denominator in our ratio, then that means that yes, they are equivalent. If you go from 4 to 12 and you go from 1 to 3, you can see 4 times 3 gives you 12, and 1 times 3 gives you 3. That means this is also equivalent to this. The same goes for this. There's a relationship here. 4 to 16 times 4. 1 to 4 times 4. So these are all equal. Okay, and that is the good thing about ratios. But we have to know that when we have a ratio and we're trying to build another equivalent one, we have to be multiplying by the same number on the top and bottom of our ratio. All right, turning to the back. Suppose the ratio of the number of boys to the number of girls on the team is now 3 to 2. Create a table to show the possibilities of the number of boys and girls on the soccer team. So we have 3 boys, 2 girls, total of 5 players. What are some other options that show that there are 3 boys for every 2 girls on the soccer team? Show other options in the table. So again, we're going to go ahead and add the same number of boys every time and the same number of girls and the same number of total players. So we would get 6 and then 4 and then 10, right? So we're adding 3 in the boys column, adding 2 in the girls column, adding 5 in the total players column. You do the next one. Pause the video and go ahead. So you should have wrote 9, you should have wrote 6, and you should have wrote 15. All right, why can't I say there are 3 times as many boys as girls on the team? And the reason we can't say that there are 3 times as many boys as girls, because we have 2 girls this time. Last time on the front, we only had 1 girl. There were 4 times as many girls. This time we have 3 to 2. So we can't say it because we don't have 1 girl. There are 2 girls for every 3 boys. Make sure you get that down. Okay, so you can pause it and write it down like I have. So we can say instead of 3, we can't say there are 3 times as many boys, but we can say there are 3 to 2 as many boys as girls, which means there are 3 boys to 2 girls. You can't really say 3 times as many. So now you have to write it as a ratio like this. Can you visualize this? Hardly. So we can make what's called a tape diagram. A tape diagram or a bar model that shows there are 3 halves. You can read that as 3 halves or 3 over 2, as many boys as girls. Here's your 3. Here's your 2. Okay. Now, we have a total of 5. Now, if I wanted to, let's say that I wanted to make this, I wanted to know, well, let's say I wanted 9 boys on my team. Well, if there's 9 boys on my team, that means each one of these would be 3. Watch carefully. That's 9. And that means these 3s would also have to go in these boxes because they're all the same size. That's 6. So that means my ratio of 9 to 6 would be equivalent to my ratio of 3 to 2. Whoops, sorry. Let's make sure. If we multiply this by 3, do we get 9? And if we multiply this by 3, do we get 6? And the answer is yes. Okay, I could have put 4s in each of these. If I put 4s in each of those, I would have 4, 8, 12 to 8. 12 to 8 is another example, which if I multiply by 4 here and I multiply by 4 here, I would get that ratio. So which description makes the relationship easier to visualize, saying the ratio 3 to 2 or saying there are 2 halves as many boys as girls? And the answer is saying 3 to 2. It's easier to visualize with a tape diagram. Okay, so that is our lesson for today, and we're going to continue talking about equivalent ratios in the next video as well. And we're going to start working with these unifix cubes also, because what you can do with these is let's say I had a ratio of, again, 2 to 3. And let's say I wanted to make, I don't know, let's say I wanted to make it, now do you see how this is a total of 5? That's 2 to 3, 2 orange, 3 blue, total of 5. Let's say I wanted to make it 15. Well, if I wanted to make it 15 and keep the ratio consistent, I would need to continue adding 3 blue, because you want to keep adding the same number of blue, and you want to keep adding 2 orange. So if I did that, I would only get here 6, here 4, that's 10. I need to add 2 more orange, that's 12. And I need to add 3 more blue. So I have 3, 6, 9, 11, 13, 15. So now I have 15. Okay, I'll back up a little so you can see. But you can see I have 15. So that's 2, 4, 6, 8, 10, 15. And you can see my ratio is still the same. For every 3, I have 2 orange. For every 3 blue, I have 2 orange. And for every 2 orange, I have 3 blue. So we're going to start investigating with that more tomorrow. But thanks for watching for now. And make sure you check the assignment folder to see if there's any assignments. Bye-bye.